Hey there, folks. Okay, here is the lab data that you got from those two videos that you just watched. So I did the reaction of sodium, lithium, sodium, and potassium, and then you saw the video of students doing some observations of aluminum, magnesium, and calcium. Here we go. So lithium, sodium, and potassium have a very fast reaction with air. How do we know that? Well, we store them in oil to keep them away from air. Lithium, sodium, and potassium have a very fast reaction with water. They basically start to fizz and sometimes explode as soon as they touch water. If a reaction occurs with water, it's exothermic. In each case, it gives off a bunch of heat. Sometimes it gives off enough heat that it ignites the hydrogen gas that has been produced. Yes, they all produce hydrogen gas in water. They produce it very vigorously. And they turned phenolphthalein pink because they're all metals that will bond with OH ions and make things like LiOH, NaOH, or KOH. Those are bases, and bases make phenolphthalein pink, the high pH. Okay. Then in the second video, you saw some reactions of aluminum, magnesium, and calcium with water. Okay. So aluminum was the shiny stuff, calcium was that crusty looking stuff, and magnesium was the little ribbons with some little specks on them. So what did we see? Aluminum had no reaction at all with water, it just sat there. Magnesium had a very slow reaction with water, calcium had a medium reaction with water. Okay, basically aluminum and reacting with the air. Sorry, I was talking about reacting with the air first. Aluminum is very shiny, so it has no reaction with the air. Magnesium, it looks kind of speckled, so that means it's having a slow reaction with the air. The calcium looks really crusty, so that means it has a medium reaction with the air. Reaction with water, aluminum did nothing. Magnesium kind of reacted a bit. Calcium definitely reacted with the water. Okay, aluminum, we don't really think it reacted and it wasn't exothermic. Magnesium, it was hard to tell if it was exothermic, but the calcium test tube definitely felt hot. That was exothermic. Aluminum did nothing. Magnesium, there were a few bubbles. Maybe it produced a little bit of gas that was visible. Calcium definitely produced a whole bunch of gas. It was produced pretty vigorously. Again, magnesium, very minimal bubbling if there was any. The magnesium turned a faint pink in water. The calcium really turned seriously pink because calcium hydroxide is a base. Okay. So some general observations. Remember, things that are in the same group of the periodic table have the same number of valence electrons. That means they have similar properties. So lithium, sodium, and potassium, they all react with water because they all have one valence electron. But beyond that, you can get a little more sophisticated. As we go down a group, metal elements become more reactive. This is because their valence electrons become further and further away from the nucleus. They're more shielded from the nucleus, and so it's easier for a valence electron to be stolen from potassium than it is for lithium. Okay? Potassium has 4 shells of electrons. The valence shell is far out from the nucleus. That is more reactive than lithium, which only has 2 valence shells. So the further out the valence electron is, the more reactive that element is. So metals get more reactive as we go down a group, but they all react with water in that group 1. That's their similar property due to having 1 valence electron. But they get more reactive as we go down the group. All right, again, in the same group, we have the same valence number, so we've got similar properties. If we look across a period, think about what happened with sodium, what happened with magnesium, and what happened with aluminum. As we go across a period, the metal elements actually become less reactive. This is because it's easier to remove a smaller number of valence electrons. So sodium is going to be more reactive because it only has 1 valence electron. Okay. Aluminum didn't react at all. Well, it has 3 valence electrons. So aluminum with 3 valence electrons was less reactive than sodium with 1 valence electron. So the general trend is metals get less reactive as we go across the periodic table. Why? Because they tend to have more valence electrons, which makes them less reactive. Okay? Fewer valence electrons are easier to remove. All right, at this point, you should be able to do the CER by looking through these videos. Okay, thanks for watching.